Alright, I think it's about time to begin. Let's see if I can. There we go. Okay. So, today, I guess I will talk more about dictionaries. Let's make a new one. Dictionaries, more slicing. Okay. So I'm trying out, I just remembered that I have used a certain program for hundreds of thousands of years, and so I was thinking that I could use this to do various kinds of announcements and other kinds of things. So I guess let's see how this goes. So maybe I'll zoom in a little bit. So what kind of announcements are there for today? Homework 5 is due Friday. Project 1 will be released on Friday. And then I guess the question is, and remember you'll have 2 weeks to do project 1. So we used to have a design document, we used to have a number of other things. So I've removed the design document from the project. I think what I'm going to do instead is probably give you a starting bit of code. Alright, I'll probably do that. Because, well, for a lot of reasons, right? So, what else? I think that's basically it for announcements. I can't think of anything. Will you need documentation? Well, you'll need to document your functions, and I'll show you how to do that. I think, so if I'm allowed to say it, I'm going to try to make project 1 a bit easier than homework problems. But when I say a bit easier, I don't mean, so this is what I mean. So basically, the time on project 1 is probably going to be bigger than the time on homework 5. But the difficulty per time on project 1 will be probably less than the difficulty per time on homework 5. At least this is my kind of idea, right? You'll probably end up spending more time on it because it's a 2-week project. You're going to write more code. And so, of course, in some ways it's going to be harder because you have to make all your code work together. But any individual piece of code, any individual function in this is not going to be at the same level of difficulty as, for instance, exam 1 or homework 5. Okay? I mean, that's really my best estimate. And, you know, it's always dangerous when a teacher says anything about difficulty or time estimates, right? So back in, you know, back in the old math days, the multiplier used to be about 3 to 4. What about homework 6? Homework 6 is released after project 1 is due. So, you know, the multiplier used to be 3 to 4 times. So basically the rule was, like, if I took 15 minutes to take my own exam, then that was good, right? If I took any longer to take my own exam, then that was bad. But it's harder with programming to judge the amount of time that it's going to take. So, of course, what I always say with projects is the same thing that I say with everything else in this class. Start early, get help early, figure out the design of your project. Test your code, right? You gotta test stuff. So, yeah. Stuff like that. Okay. Alright, so this is basically what I have to say in terms of announcements for the day. I don't think I have a lot more than this. I know I've actually probably spent more time than I should have on this, so who knows? Okay. Oh, it's because it's on this screen. Nope. Okay, so for some reason, the tablet settings, what is it? XP. When I turn this on, I can switch over to this screen. Yes, I can. Okay. And so I can also draw. Actually, I don't know. I think I kind of like Inkscape. I might try to use it a bit more. Will you need to import directories like, oh, so for modules? I don't know, probably, maybe, right? I mean, you've been doing it on homeworks and stuff. You kind of might have an idea what's going on. Okay, so let's go back to coding. So let's run this one so that I know it's always this one that's running. Cool. So, okay. Let's get started. So what kind of things do we have to talk about? Do we have to remember about slices? Do we have to remember about dictionaries? So let me do this lecture in reverse order. So let me spend most of the time on dictionaries, and then basically I'll just go back to slices and I'll spend the rest of the time doing slices after I'm happy that dictionaries are done. So, so what is a dictionary? So a dictionary in Python is a mutable object. So it's important to remember that it's that the object is mutable. That is like a list, but instead of using in order integers, I guess I can make this a big comment. Are dictionaries similar to maps? Yeah, in a way. Not the map keyword in Python. I shouldn't. So, I'll say yes to that question. If you mean like Java, like hash maps, then yes. So in Java, dictionaries, I think are they called hash maps? Yeah, it's a hash map in Java. In Python, they're called dictionaries. In Ruby, they're called I think they're just called hashes. So like Ruby hash. Yep, it's just called hash. So in general, yeah, these are called hash tables. When you get to data structures, you'll learn more about how they work. So there's actually a way that I shouldn't say in a way. There is a way that they actually work. So basically, what you should think of a dictionary as doing is basically creating a big list, and then it basically takes each key that you use in the list and it hashes it and then uses that as the index. And now, of course, you might ask, well, what if two things hash to the same index? Take 341, that's called a hash collision. So, but the point is that basically what you need to know about it is that it takes keys as indices and assigns them to values. So that's how it works. So so basically, let's create a new dictionary. New dictionary equals, or let's not call it new dictionary. Let's call it Star Wars. And let's say A New Hope, right? That's 4. What's the next one? Empire. That's 5. The next one, Return. I know I'm kind of going through them, and then that's episode 6. Let's see, Phantom Menace. So what do we call this one? Menace. This is 1. Clones 2, and what was the last one in the prequel series? Oh God. Star Wars prequels. Revenge. Revenge of the Sith. Revenge. 3. Cool. So here's our dictionary. And now you might think, like, if you created an array of these things. Yeah, I'm more of a Star Trek fan anyway. So, yeah, okay, so we can go for movie in Star Wars. Print movie. Yeah, that's a good one. So what if we print out the movie? Here's what we get. So here's the thing. Remember that if you do a for loop through a dictionary, you're going to get the keys. That's not the values. Okay? So this is one of the first and most kind of, what should I say? It's one of the first, and the most kind of counterintuitive things that you might get to when you're dealing with dictionaries. Eventually it kind of makes sense why it should return the key and not the value, but the reason why it's going to return the key and not the value is because the point is that a dictionary is more about the fact that a key maps to a value rather than just having a value in a dictionary, right? So if I change these numbers, right? If I change this number to 3, you would say, wait a second, that's actually wrong because Empire Strikes Back is 5. And so you would say that it doesn't matter that 5 is in our dictionary as a value. What matters is that Empire gets mapped to 5, right? It's like an important pairing property. So anyway, okay, so all right. What else should I say about this? So if you ever want to get a value, so we can always print out Star Wars, and we can print out, say, Menace, and maybe we can print out Star Wars clones. Whoops, clones. Now, you might be, so just to recall, if we do this, we'll say, okay, Menace was 1 and clones was 2, and then what we'll say after that is that we'll say, what about Star Wars Last Jedi? And so what's going to happen here is we're going to get, ooh, look at that. That's pretty nice, isn't it? Let's see if I can run it again. Yeah, that's better. So, key error, Last Jedi, right? And what does that mean? What that means is that Last Jedi isn't a Star Wars movie. So basically the idea here is that dictionaries are going to throw a key error if you put in a bad key. So remember how to prevent this. So basically, what you can do instead of this is you can say, if Last Jedi in Star Wars, print Last Jedi is a Star Wars movie. Else, print is not a Star Wars movie. The keys are always the string, so the keys can actually be integers, the keys can be, remember the keys are allowed to be anything, so keys can be bools, ints, floats, strings. Anything immutable. And by anything immutable, I mean keys like this. So bools, int, float, string. So it says Last Jedi is not a Star Wars movie. Gives a lot to think about. So, yeah, in the loop, print Star Wars movie will give the... Nope, it'll be the opposite way. It'll give the number and then the name. So if you print out, for instance, Star Wars movie, and then the movie, it'll print out 4, A New Hope, 5, 6, 1, 2, 3. And so notice that this thing is not in any particular... The only order that this thing is in the order that we kind of threw everything in the dictionary. So remember that dictionaries are not guaranteed to have any particular order to the keys. All right. Can't be a list. What do you mean by that? I'm sorry. So okay. So is it possible to create a dictionary like this? Weird dictionary. True will map to 17. The number 3 will map to 5, and then 3 will map to 3, and well, 3 will map to 4 because I want it to be different, and help will be like, what is this? So keys can't be a list variable. That's true, right? Because lists are mutable. So basically, no lists. And also you can't have dictionaries. And the reason why you can't have lists or dictionaries is because they are mutable. So is this allowable? Is this okay? So let me define what I mean by okay. First, I mean, will this explode? Like, is this a syntax error, a key error, a horrible error, right? Some kind of thing like that. The answer is actually, well, I don't know. Let's run it. Nope, it doesn't explode. So it can be defined. So now what if I say for key in weird dictionary, print key and weird dictionary of key. It might be glitchy. Sometimes it's glitchy. Maybe I'll shut it down. We'll see. I mean, you don't really need to see my face. Sorry about that. I don't know why it does that. Let me see if I can unplug the camera and plug it back in. Well, I don't know if I do that. It might. Okay, I don't know why it's doing that. I'm just going to shut it down for a bit. You can still... You don't need to see me. Right? And it is kind of distracting. Alright. Okay. Well, it's my fault for buying the cheapest possible webcam. So, okay. Anyway, let's continue. Alright. Well, it's still kind of glitching, but I don't know why it's doing that. Okay. Cool. Anyway, so basically, let's just look at this one now. For key in weird dictionary, we're going to print the key and the value at the key, right? So this prints the key, and remember, when you access it, this is called the value. So let's do this. And so we see here, we get everything. So true maps to 17. The number 3, the string the number 3 maps to 5. 3 maps to 4. Help, what is this? Help maps to what is this? Right? So, okay. So this is a horrible dictionary. So why don't we do this in general? And there's a lot of reasons. So, what's bad about this? Generally, the thing is that all your keys should be the same type. And now, this is not a rule. This is just good practice. And the reason why it's good practice is because, for instance, if your keys are strings, if your keys are names, if your keys are some kind of object, then you want to be able to maybe concatenate to that string. And if you have integers and strings as the keys, yeah, if you do anything in a loop with it, it's going to do something weird, right? Yeah, exactly. So if you use weird dictionaries with different types of keys, then loops are probably going to break, are likely to break. Because you're just going to be stuck, like, oh, well, is this one an integer? Is this one a string? Is this one a whatever? And so the thing is that, like, it's going to be kind of difficult to deal with. The other problem is that, well, actually, that's the real big problem. It's just that if you ever loop through it, it's likely to just cause you all kinds of hassle. It's also bad because, you don't really know what kind of thing is popping out of the loop variable. So when you have the for key in weird dictionary, you don't you don't really know what that key is. So that's a problem. Key definitions can be, as I say, keys can be ints. Can we print the type of key? Yeah, but yeah, you can definitely do that. Like if you print the type of the key, you can do that. That's not a problem. The only problem is that once you do that, then you see the issue. Like you have a boolean here, you have a string, you have an integer, you have a string. It's not. Yeah, I don't know. Well, generally, it's better to just know, for instance, whatever dictionary you create. Like, if it's a dictionary of, say, students, right, it would be a dictionary of, Sam. And Sam has a 94 in the class. And Jill has a, 71, and Ryan has a 83, and Samantha has a 92, and Billy has a 44. I don't know. So, all names extremely invented. So, yeah, you could definitely do that. You could say, instead of this, you could be great student, Jill sits up front. Ryan talks too much in class, etc. Right? Samantha, whatever. I mean, understands recursion. And I guess Billy likes binary, right? And so you could always do for person in students. And the good thing about this dictionary is that that the keys are strings and the values are strings. So that should make you happy, right? So you can print out, you know, I guess, what would we say? Is a student, and our comment about them is something like that. So, so you can't quite do that. Oh, you mean the values can be lists? Yes. So the values for students could also be, like if we did student grades, for instance, instead of being a string, you could also have, for instance, like, 4, 5, 6, 7, 8. I guess Jill gets what? 1, 5, 7, 9, 11, right? Let's make this 12, just so the different numbers. Let's make this 14, and then let's make this 87. Right, so basically here, yeah, so remember that the keys have to be immutable, but I never said that about the values. Values can be anything. They can be mutable, immutable. They can even be dictionaries. So you can have dictionaries inside of dictionaries, inside of dictionaries, inside of dictionaries, etc., etc. So, so the thing is that it's good if both the keys are all of the same type and all the values are the same type. The reason why you want all the values to be of the same type is the same reason that you want all the keys to be of the same type. Because, for instance, you can always go like for student in student grades, and then you could say like, input, what did the student get on assignment 6, right? And so then we could say grade equals this, and then we could also say student grades at that student dot append grade. So let's just see what happens if we do this. So I guess 4, 18, 19, 23, 55, and 1. So what we see here is that we can add values into the dictionary, not into the dictionary this way. We can add values into each of these lists by accessing that list, right? So this is accessing the list, right? Because student grades at student is a list, and then appending the grade is calls append on that list inside the dictionary. Okay. So I do want to teach some new stuff. So here's some new stuff. Well, I guess before I do, let's just remember. So for instance, if we ever wanted to add a new student in here, we could always just add like student grades at Ursa, and this could be, say, 1, 7, right? So, and then we can print out the student grades, and we will see students' grades, so it's both plural. Let's give them all 5s. That's the easiest way to grade something, is just give everyone 5. And so basically here what we see is we have Sam, Jill, Ryan, Samantha, Billy, and at the very end we have Ursa. And so, or maybe I should... So anyway, so the idea here is that, like, what am I thinking? Right, so adding values to a dictionary involves just accessing the element in an assignment, like this. And then, of course, the question is how let's say, oh no, I didn't want to add Ursa, I wanted to add Ezra. So what we can always do is we can always delete students' grades at Ursa, and then we'll print out the student grades again. And then instead of Ursa, we can add, it's like, Ezra. And Ezra's different. So this is basically a way to... And everybody gets 5s again because oh, someone got a 55. What's up, dog? Alright, dog. Hang on, dog. Where are you going? Yeah, Billy got lucky this time. So the point is that, you see here, we printed out the student grades, and now here we've added a new person in here, and everyone gets 10 now, because 10 is a good number. And so here you see what I've done, right? I've removed Ursa out of the dictionary by deleting student grades at Ursa, and then I have called student grades at Ezra, and I've added it in. Is it possible to convert a list to a dictionary? Not really. So can you go list to dictionary? The answer is no, not really. What you can do is you can go from a dictionary to a list. And the way you can do that is you can make a 2D list. So you can say, for I in range, say, no, let's just say for student in students' grades. You can basically say student list equals empty list, student list dot append. And we can actually just append a list like this. We can append the student and student's grades at student. And so once we do this, we can print out the student list. Well, you can loop through a list and then add it to a dictionary, but the problem is, the reason why I'm saying you can't really is because a list is just values. You don't really have keys. Unless, of course, you want to just make... I guess, okay, so maybe I'll change my mind. You can, if you just want, like, the thing at position 0 to map to, like, array of 0, and the thing at position 1 to map to array of 1, etc. I mean, if that's what you want, then that should be okay. So if you want to convert back from a dictionary to a list, you can do this. And so here is the list that you would get. You would get Sam as the first entry, and then his grades, Jill, and then her grades, Ryan, grades, Samantha, grades, Billy, grades, etc. I don't know about that. Say we declare an empty dictionary and do students list values equals empty list. I don't know. So here's my hint to you. Play around with this stuff. There's a lot of stuff you can do. Basically the stuff I go over is just the stuff that you absolutely need. So if you want to try to, I mean, really the right answer with all of programming is always try it out for yourself. You know, play around until you break things. So, okay. So, yeah, let's actually see if we can convert a dictionary to a list. Or, I mean, a list to a dictionary. Let's see what this does. Or maybe we'll convert... I'm a little confused as to what this is going to do. Unexpected. So it doesn't like it. Value error. Dictionary update sequence element 0 has length 1, 2 is required. So I wonder if you can kind of do it like this. Maybe? Okay, so that actually worked. So you can convert this specific weird kind of 2D list thing into a dictionary where basically element at 0 maps to element at 1. So this works. Let me just say, I think this might be the first time I've ever done that. And also, you see, it doesn't love it. It kind of wants it wants an iterable yeah, it wants tuples here. So it actually, I think it might be more happy if you do parentheses. But either way, yeah. So it's happier that way. Okay. So there's also 2 more things. Whoops. 2 more things I'm going to teach. Well, 3 more things. Teach, but So the first thing I'm going to teach is not so it's actually useful. So what if you have a dictionary, right? Let's say that we have can I explain parentheses versus brackets? No, not going to do that. Basically, well, okay, fine. Parentheses are tuples, brackets are lists. So if you've ever wondered, is there an immutable version of a list? Yes, it's a tuple. Tuples are denoted with, like, ABC rather than So, okay. Yeah, tuples are kind of... The thing about tuples is that you don't technically need them for this class. So, and if you're wondering, like, why don't we teach them, it's because they're basically lists. The only thing you can't do is access, or you can't insert things into the list or remove. So, yeah. So the first thing I want to teach is like the dictionary.get function. And so the dictionary.get function, what it's going to do is you want to put in a key here, and then you want the second argument is the default value. And so let me explain what both of these mean. Well, first, if doing the dictionary.key, that's the same thing as basically doing like my dictionary at the key. So why do we have this get function? The reason why we have this get function is because if key is not in my dictionary, then basically what it does is it gives us back the default value. Else it'll give us back my dictionary at key. So that's what it basically does. So here's like an idea. So basically what we can do is we can say students grades dot get and say Samantha. and in the default argument we'll put empty list, right? So print students grades.get Samantha with an empty list, and then here we're gonna do say what's a name that's not in the dictionary. So the default parameter, if there's nothing else in here, is none. So you do define the default parameter, but I think it also comes with a secret none put in there if you don't put anything else in. So let's say Archibald, which is a great name. Let's see what happens when we do this, and then let's see what happens when we do Archibald. So, or dictionary. Is the default value a value in the list? No. So, yeah, basically, the good news is I was actually right about that. The default value is pre-programmed to be none. So here, if you do studentsgrades.get Archibald, Archibald's not a student, so it's not going to get anything. But sometimes you don't want it to return none, you want it to return something else. So here you see that for Samantha, it returned her grade list. For Archibald, it returned none. And then when we set this default value, it returned this default value. Whatever you stick into the second argument becomes the default value. So none is its own special type. Yes, that's true. Sometimes you want it to be none because what you can do is you can say if students grades dot get Archibald, but the problem is that this will print yep. So there's two ways in which this can print yep. The first way that it can print yep is if Archibald is not in the dictionary, or is in the dictionary. So there's two ways this can print yep. If Archibald is in the dictionary, then yep. And the other way that it can do it is but it can also print nope, I guess else nope. When the value is non-zero or null or whatever. But on the other hand, nope is printed if is not in the dictionary. But it's also printed if Archie's grades are empty list. So for instance, if I add in I'll get it eventually. So if we do this, then we're actually going to print out nope. And so you see that nope is printed out in the end. And the reason why is because even though we've added something into the dictionary for him, and then here it'll print out yep. So can you do any variable equals none? The answer is yes, but also remember that none evaluates to false. So you only have to ask if blah var, right? So if blah var equals none, you can say if not blah var, or if blah var is, well, technically, so PyCharm might yell at me for this. You can do this kind of thing. So technically, and in this course, avoid doing it, even though this is actually better. This is like the one thing that I'm going to tell you to avoid doing, which is actually better in Python. So PyCharm is going to tell you, it's going to say blah_var is not none. And so technically that's the correct Python for this. But the problem is that I don't want to allow the is keyword. So don't do this because is forbidden in 201. And the reason why is forbidden in 201 is not because like this one line of code would be better with is. The reason why is forbidden is because is not equal to this. So basically, let me show you an example of why is bad. So if we have a list equals 1, 2, 3, 3, 4, 5, and b list is equal to 1, 2, 3, 4, 5, and then we say if a list is equal to b list, print they are equal, no contractions, and then we say they is equal. So you see that here it printed they are equal. And here it did not print this, right? It didn't do this. So what the heck, right? So this is why we don't teach is, okay? The reason being that what is doing is it's comparing the underlying Python object. It's not testing the two lists to see if they're equal. It's asking, are these two lists the exact same place in memory? Are they the same object, right? Because if I did something like this, now I say if b list is equal to a list, and remember this b list is now a reference for the a list object. So now they is now equal, right? So I'm going to run this, and I'm going to do 54, I guess. And so you see, yeah, so this is why we generally forbid this. We generally forbid it because I promise you that you almost never mean this. Okay? So all the assignments, all the projects, all the quizzes, all the exams, every homework, we want this, okay? Not is. All right? And that's the reason, because if you do is, then you're testing for some even stronger equality, an underlying object. Yeah, it's the thing is that it's not really teaching you programming so much as confusing a lot of introductory students. And so that's why we get rid of it, because I know that it exists around online and it's out there, right? Like, and so you'll see solutions with it, and this is the problem with it. So yeah. Okay. So now let me teach the last two things about dictionaries. So what if you want to get the keys out of a dictionary? Well, there's a keys function. There you go. That's it. So you see that it actually prints out as this dictionary keys, right? And what if you want to get the values out of a dictionary? There it is. So, but in a way, I want you to avoid using this function. Not because it's forbidden, but because, what do I say about it? I guess the thing to say about it, it's not forbidden, right? It's allowed. You can do it. But I think the problem with it, why is the dict keys and dict values added to it? The answer is because Python decided that it's not good enough to just be a list. It has to be some kind of weird list. And how do you prevent that? Good question. Here's how to prevent that. Just cast it as a list. Will it make the code more complicated? Not really. So, but here's the thing. Here's the thing. Why are you ever going to call studentgrades.values? The answer is you don't care what the grades are unless they're, I guess what I should do is this. You don't care what the grades are unless they're attached to a person, right? Like, you don't care, for instance, if you did, print list of Star Wars .values, right? So look at this, 4, 5, 6, 1, 2, 3. What does that tell you, right? I mean, this tells you just about nothing, right? And it's not a mistake, right? It's just like values are garbage unless you know what key they came from, right? And so that's the kind of idea for dictionaries. Like if you don't care about the keys, then you can generally just make a list. Yeah, it's a little bit like magic values. What it really is like, what does 1, 2, 3 mean in the star? Yeah, exactly. There's no context. There's no information. This isn't helpful usually, right? So, I mean, occasionally you'll need this function, but I think generally what I'll say is like, almost never do I make any project or anything which has a tricky enough problem that actually requires you to hit the values on a dictionary. Everything I've ever done with dictionaries in 201 has always required you to just do it in the standard way. You map from keys to values, you get the values from their keys, and you understand what the values mean based on the key it came from. And that's the whole point. And so I generally don't make anything. Can you also use for student grades print? Yeah, I guess you can. So the other thing you can do, so let me just say the last thing is that you can actually use key in studentsgrades.keys. But this is the same as just saying key in student keys or student grades, right? So the point is that if I see a keys function after this, generally what I know is that, like, it's evidence that, basically I usually take this as evidence that that this came from the internet, from a programmer who doesn't really know Python well enough. So they might be a good, they might be a decent, good programmer, could be better than me, but they just generally don't know Python well enough, because if they're using this .keys method, they don't know that it's not necessary, right? So that's the idea. So you can do this, it's just kind of evidence that it's like, why? Because you don't need to, because if you just take this off, it works. So basically, these are two methods that we usually teach in this class. But I'm actually going to say, in general, unless you really need them, I would say don't use them. Like, the only time when you could ever really need them is if you need to make a list of the keys. So this is probably like the single really useful thing you can do with students' grades dot keys is just making a list of the keys separately from the values. Now, sometimes you do want just a list of the keys, because remember, keys are like the names, so you can use those later and re-access the values. But if you just have the values, then it's very difficult to know what keys they came from. Okay, cool. So let us proceed back to slices. So let's do about 15 minutes on slices. So, what do I want to say about slices? Basically, you can slice strings and you can slice lists. So remember the notation for it. The notation for it is that a slice is equal to, say, something like this. Let's put all this up in dictionaries. And so remember what this does, right? It starts at position 3 and it goes to position 8. So what's position 3? This is 0, 1, 2, 3. So here's position 3, 4, 5, 6, 7. And remember, it doesn't go up to 8. So R is at position 8. But remember that slice is like a half-open interval. It includes, excludes. So it's not really inclusive. It's not really exclusive. It's inclusive of the lower endpoint and exclusive of the upper endpoint, which, as people will remember, it's a bit like range. So there's no step argument in slicing, right? The answer is there is a step argument, yeah. So generally, at least in the past, we've forbidden it. Yeah, you can basically do this. So if you do this, then you start at 3, which is this L, and then you go up by 2. So the next one is this one, the next one is O, and then you get to R, and then there's nothing after that, right? So, well, so it's, the step argument is generally forbidden into a 1. I don't really care so much. For now, it's forbidden. Let's just stick with that. If I decide to allow it, maybe I'll talk about it. The thing about the step argument, the thing about it is that like slices are usually so difficult for students to actually understand that we definitely don't want to overload you with the step argument as well. So the last thing I want to say about slices is that you can do slices with negative indices. It's not forbidden for range, so it's allowed for range, not for slices. I know it's inconsistent, and that bothers me too. I'll think about it. So what's the main purpose of... what's the main purpose? So what if we had an input statement and we said, like, enter a date format. And let's say it's year slash month slash day, right? So then what you could do is you could say, I know that the year is equal to the int from 0 to 4, right? Because, for instance, yeah, unfortunately. Okay. So then you can also do month, for instance, which is equal to the integer of what? Isn't slice a function not the same as... Well, so slice is a thing that... Right, so let's not even get into the keyword slice. Don't use this, right? Okay, so how are we going to get the month, right? So we count up here, we get 0, 1, 2, 3, 4, 5. Month starts at 6 and goes to 7. So we go, so remember, we want to include 7, so we got to go to 8. And then, for instance, day is equal to S of, and so this would be 8, and this one is 8, so this is 9 and 10. And so remember what we can do. We can just say 9 till the end. Or you can do 9 to 11. So let's enter 2020 slash 10 slash 14. Boom. Haha. What did I do wrong? Let's see here. 0, 1, 2, 3, so that's 4. Ah, this is 5. That's 5. I think that should fix it. There we go. So it's important to count correctly. Of course, so this is one application of slicing. Another application... Oh, I tried to convert, basically... It wasn't quite out of bounds. I had accidentally taken I had miscounted, right? Because this is 0, 1, 2, 3, 4. This is the 4th position, and I had started here at 6, and so I had missed 5. So this is actually 5th position, 6th position, 7th position, 8th position, 9th position, and then 10 is just the length of the string. So yeah, you can do 2020, 02, 02. And so out of bounds doesn't show error. That's right. So remember, slices are kind of forgiving about index errors. Ugh. Yep, that's true. So yeah, if you print out like, hello there, and yeah, you do basically what Pravar is saying, it's going to print out, 2020 slash 05 slash 06, and it's going to just print out hello there. And you notice that there's nothing else after this. This is just the last end line from the print statement that ends the program. So yeah, it disobeys the general Python philosophy, which is always throw errors. Okay. So if that isn't hard enough, here's something else that you can do with slices, but I'm actually thinking that, at least for this class, I might avoid requiring this. Slices are important to format text. Yeah. They're good for taking out specific blocks if you know exactly what's in each block. So slices are good for that. Of course, they are a little bit dangerous if the user inputs. Remember, they're a little bit dangerous though, because if the user ever inputs like 2020-22, this should explode, right? Because it's going to try to convert a 2/. You need to have the format exactly as is. So, in a way, this is a decent example of how to use a slice, but here's actually kind of a better way to do it. You can actually just say, and then you can say year is equal to So if you do it this way, you can get a little bit better results. So here, this one you have to do 2020, 05, 07. And this one you can just do 2025, 7. Can you have a variable that is assigned to the slice integers that you can manipulate using input? I'm not 100% sure that I understand what you're asking. Let's see, can you have a variable that is assigned to the slice integer? Yeah, I guess. Try whatever you're thinking out and see if it works. Maybe you'll have to show me what you mean in code. But anyway, so this is actually, I think this is actually a little bit of a safer feature here if you just have s.split. Now, of course, this requires them to enter in a year, a month, and a date, but it doesn't actually require them to enter in the leading zeros, which, of course, like users, right? Users will disobey everything you ask them to do, right? So, if you say, user, enter in year, month, and day, they will enter in literally whatever they want. So, oh, sure. Yeah, absolutely. So, for instance, like, yeah, you can definitely do that. Yeah, sometimes I forget to say it, but wherever I have numbers here, like literals, you can also have, for instance, you can have like year start equals 0, year end equals 4, and then you can slice from year start to year end, right? You can do that too. Or, I mean, it doesn't have to just be constants. It can be, regular variables as well. So, for instance, you can basically so 95% of all programming when you're doing like a front end development stuff is always just trying to prevent users from sending absolute garbage data back into your back end, right? Because the thing is, like, if your front end is a bunch of inputs, and I mean, like, radio buttons and buttons are okay because you can kind of control the input, but the worst thing ever is just a text box, right? User, enter text, right? Because the user can copy and paste anything into there, right? And click the go button. And so your program has to basically, in general, it should just reject almost everything, except for the things that you want to take in. You always have to be very careful. Yeah, I mean, so any... right. Insert the XKCD joke about Johnny Tables, right? Oh, I guess I can actually just show the joke. So, yeah, your sons are having some trouble. Oh dear, did you break something? Did you really name your son? Robert, end quotation, end paren, semicolon, drop table students. Yeah, little Bobby Tables. So, so the moral of the story is that this is user input, right? So that's why you always have to be a little bit careful. Anyway, I mean, also there's a lot of things, but yeah, just So I mean, if even if you don't read the textbook, you got to read XKCD. It's like required reading for a CS major. So anyway. Okay. So the last thing I will mention in the last 2 minutes of class is that negative slices exist, and they count backwards. Yeah, so the good news is that not only do I sanitize most of my inputs, but also I don't use SQL. But anyway, so for instance, let me just show you this. Well, this should be empty. Okay, am I back? Am I here? Let me see if I F5 what happens. I suspect it's a I suspect this might actually be a YouTube problem. But you know what the good news is the class is technically over. So I could teach negative slices, but I'm not gonna. We're done. Maybe if I'm nice, I'll make a video on negative slices. Like a separate thing. So, yeah, that's actually... so actually this is just a blank line. What you would need to do is you need to do a slice from, I guess, -5 to -1. So, nope, yep. So, basically, if you can figure out why this is the thing, right? Because it goes from the position of -5 all the way Oh, good God. So basically, if you count backwards, this is -1, -2, -3, -4, -5. And it starts here, so you go -4, -5, -4, -3, -2. And then remember, you go up to but don't include. So that's why we get this. Yeah, I guess you could actually just do this maybe. And that'll do it. Or you can do maybe this. Oops. And that'll do it too. Yeah, so this is it's basically counting from the back end of the string. And the only thing to keep in mind, what's the purpose of negative slices? Oh God. I don't know. Well, so the purpose is really like to add features to a language so that like if you want to do this kind of thing, then you have this option. So I shouldn't say that there's any like specific application, for instance. You don't technically need them. Sometimes it's just nicer. Like if you know, for instance, let's say that you have some function that it always returns like some string, and then the last two things are 2 digits. And then you can say like so if we call a function and let's say, blah is equal to function. Well, I guess I have to put function above it. Then we can always just do like blah of -2 to the end. And that'll get us So in this case, it was 91 for whatever reason, right? So basically, if you know that the last two things are always a number and you're interested in it, then yeah, you can do that. Yeah, lecture's technically been over for about 5 minutes, but I always answer questions and that kind of thing, so I'm always willing to. Printing out an output, I wouldn't say that. It's a different way to access a slice, right? So you can access a slice in the forward direction, or you can access slice with negative indices. And you can generally do the same thing both ways. The only reason why I'm a little nervous to say like it's any particular application is because technically you can always do it without negative slices. So you can't use negative slices? No, you're allowed to use negative slices. But here's the thing. Negative slices will never be the trick answer. So I'm not going to give you a problem. There's no problems. No problem will exist. Where, basically, everything makes it mega hard, but negative slices makes it 2 lines. So this will not be done. Now there are problems like this. There are some tricky things that you can invent, such that negative slices are kind of like the right answer in terms of slicing. But again, I'm never going to make a problem in this course where it's going to be like that, because my goal is only to really test you on positive slices. All right. Only positives. All right, so I think that's it. Let's seal the ports. Guess I have to end the lecture.